Hello, my name is Sujay Park. I'm from OxWires. OxWires is the only company providing nano ceramic coating on conventional bonding wires. I'm going to talk about gas-free, foaming gas-free nano ceramic coating, Al2O3 aluminum oxide, and TiO2 titanium oxide. We want to apply nano ceramic coating on silver wires so that we can replace a gold wire. OxWires won the award of Best in Track Presentation at IMAPS Symposium in 2023. The title of the talk was Al2O3 Coated Bonding Wire with Electrical Insulation and Adhesion Promoter. As an introduction, I'm going to talk about challenges associated with conventional bonding wires. Then I'm going to talk about a solution. And then I'm going to show you how to apply nano ceramic coating using PVD and ALD. Then I'm going to talk about experimental data of bondability, ball shape, and reliability and package level testing as well. Why we need to care about challenges for conventional silver wires. On your right hand side, you're seeing a gold price has doubled up over the last couple of years. Gold was expensive, and nowadays gold is very expensive. And then we want to stay away from a gold wire. How do we do that? Can we make use of a silver wire with some sort of special coating, like TiO2 coating? Then we have to know about the shortcomings of conventional silver wire. Shortcoming number one is the surface oxidation and corrosion. Silver and copper wires are susceptible to surface oxidation and corrosion. So it requires a use of foaming gas during wire bonding operation. Without a foaming gas, you're going to get off-centered ball formation. Off-centered ball doesn't allow a good bondability. On the top of that, foaming gas is a dangerous gas because it contains a 5% hydrogen gas, so that the wire bonding assembly people do not want to make use of a foaming gas. Why we need a passivation for conventional silver wire is shown when we apply a harsh conditioning of 150 degrees C for many hours at ambient environment. A silver wire experiences a surface oxidation and corrosion. On your left-hand side, no coating, no passivation is applied. You can see a color change of the silver wire surfaces. And if we do the wire bonding with these wires, you're going to get a very serious off-centered ball, or OCB. Simply speaking, ball is not symmetric. No forming gas was used for this wire bonding. However, after we apply a TiO2 passivation on the surfaces of the silver wire, when you're right here, blue color, you're seeing TiO2 passivation. Even after the harsh conditioning, you're gonna get a very nice FAB, free air ball, symmetric ball shape. No OCB, even when no forming gas was used, you're looking at a 0.9 mil diameter of the silver wire with a TiO2 passivation, and a 0.8 mil diameter and 0.7 mil diameter as well. No forming gas was used. And TiO2 is not the only passivation we can apply. On your right hand side, you can see the Al2O3 was applied on a 1 mil diameter of the silver wire after exposing the wire to 85 degrees C, 85 relative humidity for many hours. No color change occurred. It indicates that a TiO2 passivation and both and Al2O3 passivation protect the surfaces of the silver wire from oxidation and corrosion. We can also apply the passivation coating on the surfaces of a conventional copper wire as well. On your left-hand side, no passivation is applied to the copper wire at very high temperature, like 250 degrees C. At the end of the one day, you're going to get very serious copper oxidation, very serious color change. But on the other hand, after we apply the Al2O3 passivation on the surface of the copper wire at very high temperature, even after the 8 days, there's no color change, indicating that this Al2O3 passivation protected the surfaces of the copper wire from oxidation. You're seeing the FAB free elbow shape that is very symmetric. You don't get no OCB by making use of Al2O3 passivation coating on a conventional copper wire here. You can see the boards are very round. At the bottom, 1.6 and 1.2 mil diameter was used for this testing. And we left the Al2O3 passivated copper wire on the floor for 1 year. But when we did wire bonding operation, we can get a nice wire bonding as well, even after the 1 year. Even after 1 year. I have to emphasize, no forming gas was used. So in summary, why we want to make use of a passivation for silver wire is because the gold wire is very expensive, and we want to replace the gold wire by making use of a silver wire, having a special passivation coating like Al2O3 and TiO2, because this passivation is going to provide a protection from oxidation and corrosion. So at the end of the day, you're going to get a 50% cost reduction or more relative to gold. And I'm going to show you data later on, but in summary, the bonding strengths are almost same between gold wire and a passivated silver wire, and IMC reliability is almost same, and bondabilities are the same, and workabilities are the same. I'm going to show you the data on the next slide. Then I want to show you the coating systems, two coating systems of ALD, atomic layer deposition, for Al2O3 coating. And on your right hand side, you're seeing a PVD, physical vapor deposition of sputtering. The biggest difference between two coating systems are sputtering uses a roll-to-roll method, such that the wire is in motion during a deposition operation. On the other hand, ALD makes use of the batch type, means that a wire does not move during a deposition operation. And As of now, sputtering is more expensive than ALD, and we want to diversify the coating cost options as well. And now I'm going to show you a lot of experimental data. Number one, ball shape. On your left-hand side, conventional AG wires means that no passivation is applied. I'm going to emphasize that no forming gas was used. When we look at the ball shape, it's not very symmetric or round. But after we applied Al2O3 coating on the surfaces of the silver wire and TiO2 passivation coating on the surfaces of the silver wire, we got a very round ball shape at the bottom. On your right hand side, you can get a very nice loop out of 0.8 mil all the way up to 0.9 mil as well. There's no OCB because this passivation coating protects the surfaces of the silver wires from the oxidation and corrosion. We have to look at the stitch bonding pattern. Our Nano Ceramic coating did not result in any difference in terms of a stitch bonding shape. On your right hand side, zero means zero, the zero coating, 8 nanometer thick Al2O3 coating. When you look at the fracture mode at the stitch bonding, they are almost identical, indicating that this stitch pull test, stitch pull strength is not going to change by introduction of the Al2O3 passivation coating. And I'm going to show you the data on the next slide. I have to emphasize again, no forming gas was used. And wire was silver wire 1.0 mil, 0.9 mil silver wires, and the passivation type was TiO2 and Al2O3 passivation. And on the next slide, I'm going to show you the strength of ball pull test, ball shear test, stitch pull test. Reference means no coating. And no coating, the 6.2 gram of ball pull strength. In the case of Al2O3, 6.3, 6.5, they are almost same to the no coating cases or reference. And TiO2 in the 7.1 gram, they're almost same. And when you on your right hand side, when you look at a stitch pull strength, the reference here is no coating cases that the ball shear, stitch pull strength, they don't change much at all by introduction of TiO2 passivation and Al2O3 passivation. Again, I'm going to have to emphasize that no forming gas was used. And IMC reliability is very, very important. I have to show you that this Al2O3 passivation does not change the IMC types or IMC thicknesses between wire metal and pad metals. The reason is because IMC stands for intermetallic compound. However, the coating material Al2O3 is not a metallic material, it's a ceramic. So that this Al2O3 coating does not participate in the formation of IMC at all, such that the resulting IMC is identical before and after this nanoceramic coating is applied on the surfaces of the bonding wire. And then to our customers, assemble the camera module packages, camera module. They make use of the Al2O3 coated silver wire, and they've done more than 40 testings, and everything was passed. And I want to emphasize the no forming gas was used for this package level testing.